When we do roots or radicals, I like to talk about the difference between adding roots versus multiplying. It's very similar to if those roots were variables. The rules are very similar. When you add root 5 plus root 5, it's almost like adding x plus x. You get 2x. So 1 root 5 plus 1 root 5 would be 2 root 5. Root 5 times root 5, you multiply what's underneath, so you'd get root 25, which would simplify to 5. Also, there's a shortcut for this. If you take root 5 times itself, you're actually squaring a square root, which is an inverse operation. So it's going to undo it, leaving you with just 5. Root 3 plus root 2. It's kind of like adding x and y. They're not like terms is how I like to think of it, so you can't really add them. So this is as simple as you get. When you're multiplying, however, you don't have to have like terms. Same thing with x's and y's. So if you have root 3 times root 2, you just multiply what's underneath the square root signs, and it's root 6. 2 root 6 plus 5 root 6. Again, think of it like variables. 2x plus 5x would be 7x. Same thing. 2 root 6 plus 5 root 6 makes 7 root 6. Again, in order to add these, we have to have the same radical ending. Multiplying, we can just multiply everything together. So I'll multiply the regular numbers together. So 2 times 5 makes 10. And then remember, root 6 times root 6 actually makes regular 6. So this would be 60. Again, if you needed to write this as a root 36 to start with and then change root 36 into 6, that's fine. 3 root 5 plus 7 root 2. Okay, these radical endings are not the same, not like terms, so I can't add them together. So that's as simple as I can get. When I'm multiplying, I don't have to have the same endings on my roots. So I can just multiply this all together. Multiply the regular numbers first, 3 times 7 and get 21. And then the square root of 5 times 2 is 10. And you always want to check, does this root simplify? Are there any perfect squares that divide into 10? There's not. So that's my answer, 21 times the square root of 10. 5 root 2 plus 3 root 8. There's a trick here. At first glance, you would say, oh, not the same root ending, so I cannot add these together. But root 8 simplifies. 3 root 8, I can change root 8 into root 4 times root 2. Because root 4, I know is really regular 2. So this is regular 3 times regular 2 times root 2. So that's, the 3 times 2 is 6 root 2. So now from the beginning I've got 5 root 2 plus 6 root 2. So my answer is 11 root 2. Over here, again, I don't need the same radical endings to multiply, so I can just multiply my regular numbers together and get 15, and multiply what's underneath the root. 2 times 8 is 16. I can simplify. Root 16 is really regular 4. So this is 15 times 4, or 60. To divide radicals, if you have just multiplying and dividing in your radicals and you have a radical on top and radical on bottom, just like with multiplying, we can make this into one big radical. And then we can simplify this fraction. 8 over 2 is really 4. And x to the 4th over x to the 3rd is really x. So we have root 4x. Now we can simplify that a little bit by splitting it up. Square root of 4 times the square root of x. Square root of 4 is really regular 2. So this turns into 2 times the square root of x. Rationalizing the denominator. It's not mathematically pretty to have a radical in the denominator. So just like it's not mathematically pretty to have fractions within fractions, you can't have radicals in the denominator either. This is a step that's called rationalizing the denominator. We're going to use our funny form of 1 trick again. And we're going to multiply both top and bottom by root 2, the same thing that's here. Again, this is a legal algebra step because I'm really just multiplying right here by a funny form of 1. So remember, multiplying fractions, it's no problem. First you do the top, then you do the bottom. Top, 5 times root 2 is 5 root 2. Root 2 times root 2 is regular 2. So I get 5 root 2 over 2. That can't simplify at all. That's my answer. Same thing here. Can't have the root in the denominator, so I just multiply by that root on both top and bottom. This is called rationalizing the denominator. Again, mathematically legal because I am just multiplying by a funny form of 1, therefore not changing the value of my original fraction. So my top is y times root 3y, and my denominator is 3y. Now, this y cannot cancel this y because this one's under a root and this one isn't. But I can cancel this y with this y, leaving me with root 3y all over 3. If there's adding or subtracting in the denominator, we multiply both the top and the bottom by the conjugate. It's a different way of rationalizing the denominator. So I'll talk about what the conjugate is. 5 minus 2 root 3. To find the conjugate of that, you just take the same thing, except you put a plus in there. 5 plus 2 root 3. To rationalize the denominator, we will multiply both top and bottom by this conjugate. Again, similar to above, because we're just multiplying by a funny form of 1. So we're not really changing the value of our original expression at all. Now we just have a lot of icky distributing to do. 3 times 5, 15. 3 times 2 root 3. The 3 times the 2 will make 6, so that's 6 root 3. And then in the denominator, we just have to distribute all this. Notice what happens because of the conjugate. 5 times 5 will give us 25. 5 times 2 root 3 is plus 10 root 3. Negative 2 root 3 times 5 is minus 10 root 3. Negative 2 root 3 times positive 2 root 3 will be negative 4 times regular 3, because root 3 times root 3 will make regular 3. Now look what happens to our middle terms here. And this always happens with conjugates. Sometimes I even skip that middle step. Those two, 10 root 3 and negative 10 root 3, are going to cancel out. So let's do some more simplifying. The 15 plus 6 root 3 will stay on the top. And since these two middle terms cancel, I have a 25 and a negative 12. So that will give me 13. This would be fine to have your answer like this. Sometimes your book will split it up and put the 15 over the 13 and the 6 root 3 over the 13. So split it up into 15 thirteenths and 6 root 3 over 13. So either of these answers are acceptable. We're going to do the same thing in this problem. We're going to rationalize this expression by multiplying by the conjugate of the denominator. So 2 minus root 6, The conjugate of that denominator is going to be 2 plus root 6. We will multiply by that on the top as well. Since there's 2 terms in our numerator, we have to distribute. Again, I've multiplied both top and bottom by the conjugate of the denominator. Now just a bunch of icky distributing to get our answer. 3 times 2 is 6. 3 times root 6 is plus 3 root 6. Plus 2 root 6. Plus regular 6. Now the denominator. 2 times 2 is 4. Plus 2 root 6. Minus 2 root 6. Minus 6. Take a minute to see where that minus 6 comes from. Notice in my denominator what happens. A lot of times I'll even skip those middle 2 terms of my conjugate multiplying because they always cancel out. So now let's add like terms here. In the numerator we have 6 and 6, so that's 12 plus 5 root 6. And in my denominator we'll have negative 2. That's my answer. Or sometimes the book will split it up and do 12 over negative 2, which is negative 6. And then 5 root 6 over negative 2, which would be minus 5 root 6 over 2. So either of those answers are fine. Next problem. Again, very similar. I'm going to multiply by the conjugate of the denominator. So since it was 3 root 3 plus 2, my conjugate will be 3 root 3 minus 2. Just change the sign in between them. Since I multiplied by 3 root 3 minus 2 on the top, I have to multiply by 3 root 3 minus 2 on the bottom as well. Since I have 2 terms in my numerator, I have to distribute. Now just a bunch of icky distributing. 2 root 3 times 3 root 3 will be 6 times 3. Root 3 times root 3 will make regular 3, so that'll be 6 times 3, or 18. Minus 4 root 3. Minus 3 root 3. Plus 2. In my numerator. Let's take a look at my denominator. Okay, the regular 3 times the regular 3 will make 9, and root 3 times root 3 will make regular 3, so that's 9 times 3, or 27. Again, this is the part I sometimes skip, because I'm going to have minus 6 root 3 and plus 6 root 3. Those two are going to cancel. And then my last term here, 2 times negative 2 will be negative 4. So let's collect up our like terms. This will be 18. So we'll have 18 plus 2, so that will be 20. Negative 4 root 3 minus 3 root 3 will be negative 7 root 3. And then in our denominator, these two will cancel. So we'll have 27 minus 4, which is 23. And you can leave your answer like that, or sometimes in the book they'll split it up and do 20 over 23. And then negative 7 root 3 over 23. So minus 7 root 3 over 23. We will use this same idea when we talk about imaginary numbers. We'll be multiplying by the conjugate again. So practice it now, because this is going to come back at you.